All right. Hello, everyone. So today I'm going to go over the notes for Chapter 3, Section 4, Avogadro's number in the mole. Again, like a lot of stuff we've done so far, it's something we've hit in Chem 1. So it's hopefully just going to be kind of a little refresher course. So the definition of a mole is a unit that represents a specific quantity in chemistry. So Avogadro's number is the number of atoms contained in 12 grams, or 1 mole, of carbon-12. All right. Now, how do we use this in chemistry? Well, Avogadro's number is a specific number of particles, the 6.02 times 10 to the 23rd. And remember, the particle label is like saying distance or time. It's a category. It's not an actual unit. So, what are some of the units that we can use for the particle label? Well, we can use atoms. You would use atoms when you have a substance that is just a single element. Okay. You can use molecules. You use molecules when you have a covalently bonded substance. You can use formula units. We use formula units when we have an ionically bonded substance. And one that we didn't use before, but we can use is ions. You can use ions when you have ions. Making sense, hopefully. Okay, whether you're talking about polyatomic or monatomic, either way, you can use ions when you have something with a charge. Okay, but notice it's always 1 mole of whatever substance it is equal to 6.02 times 10 to the 23rd, then whatever the particle unit is. All right. Molar mass. This is the other part of stoichiometry. Molar mass is the mass in grams of 1 mole of a substance, labeled grams per mole. The molar mass of a substance is numerically equal to its formula weight in AMUs. So in other words, NaCl, the formula weight, is 58.5 AMUs, which means the molar, or also sometimes read as molecular mass, is 58.5 grams per mole. Same numbers. Now, what do we do with that? Well, that tells us the number of grams per 1 mole. So in other words, for NaCl, that means that you have 58.5 grams of salt is the amount of grams you would need to have 1 mole of salt, sodium chloride. Okay. All right. Now, there's one more thing I want to put on this notes that isn't on here, but that we use and can be important. Okay, and that is the relationship between a formula, the moles of a formula, and the moles of individual elements in the formula. Okay, so this is sort of separate from what we have here. All right, so say we have 1 mole of water. In 1 mole of water, there is 2 moles of hydrogen and 1 mole of oxygen. Okay. The way this works is the subscripts in the formula tell the number of moles of that element in 1 mole of the compound. And you can use this as a conversion ratio. Okay? So, for example, let's kind of just showing you another example of this. If you have 1 mole of, say, glucose, okay, 1 mole of glucose, you have is equal to 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen. All right, this allows you to actually convert between any of these parts. Okay. All right, that's it for this lecture.